Welcome back, Math Nines. Let's subtract some rational numbers. This is just like the same four steps, except we're subtracting. So just be careful with double negatives. We'll do some word problems, draw some pictures. It'll be easy by the end, I promise. Okay, so when you find the difference between two numbers, i.e. that's the same as take away or subtract the first from the second, okay, is the way you can think of it. Subtract the first from the second. You are finding the distance between them on a number line. So if, we can easily see a bit of an example if you think about going a distance. If you want to know how far you traveled, you take where you started, okay, and you subtract that from where you ended, and that'll tell you the distance in between. So we're going to do something like adding the opposite. Okay, we'll come across that when we are doing like double subtracting and things like that. But let's actually just dive right into it. Let's do some examples, but we're going to have the same four steps. Okay. Um, which I'll talk more when we get to C, but basically this is saying from this number to this number. So all that's saying is we need to find the distance between them. So subtract what ends up happening. This is saying the same thing as we take the second number and subtract the first number. Okay, so this is just a little example of a distance, but in fraction notation. So we're just going to rewrite it really quick. And this is 5 over 6 subtract 4 over 3. Okay, so just like when we're adding, we need to convert to improper fraction if needed. That's already done for us. We don't need to, but we do need common denominators. So we're going to do that really quick. And I can see that, oh, all I have to do is take this 3 so I can turn it into a 6 by multiplying the top and bottom by 2. When I do that, I get a brand new fraction of 5 over 6 subtract 8 over 6. And now we can finish this off by actually subtracting the numerators. You still subtract the tops. 5 subtract 8 is going to give me negative 3. Okay, and then that is, of course, over 6, which we can divide the top and bottom by 3. Let's reduce this fraction, and we'll write it as negative 1 over 2. So we get a negative half is the distance if we were to start at 4 over 3 and go to 5 over 6. So the way to think about that is our distance here is moving left on the number line. We're going in the negative direction. But what if we were to reverse this? And if you made a prediction, you'll probably go in the other direction. So we're going to start at 4 over 3, okay? And then we're going to subtract going the other way. We're going backwards this time. We went from 4 over 3 to 5 over 6, and now we're going to go back to 4 over 3. So again, I'm going to write this really fast. I'm going to multiply by 2 to get a common denominator here. And that's going to again give me 8 over 6, subtract 5 over 6. And we can see this time we're going to get positive 3 over 6, which is the same as 1 over 2, which makes sense. When we're thinking about direction, our distance between these two numbers, okay, one was negative because we're going in the negative direction, and one was positive. We're going 1/2. Now let's take a look at a few more questions. And again, it's written in this format of from this to that. So just make sure you always take the second number and subtract the first. So I'm just going to rewrite this. The same thing is saying second subtract first. So I'm going to take my second number and I'm going to write that first. 5 over 4 subtract. This time we're subtracting a negative, so careful here. We're subtracting negative 3 and 1/5. Okay, so to do this, let's convert. First, I'm going to convert this mixed fraction. That's our first step here. So 5 times the 3 is 15 plus the 1 is 16. So I'm going to get a new fraction of negative 16 over 5. And I'm going to be subtracting here. So I keep my other number. And notice I'm keeping all my negatives up top because now we're going to use one of those rules we've seen before, which is when you subtract a negative, we turn that into a positive. So you can write it as plus plus, or I prefer to just write a giant plus sign, then you can't mess it up. Now I can see it's negative 5 plus 16. However, we don't have a common denominator yet. So let's do that. Our common denominator here, the lowest possible, is 20. So I'm going to go times 4 times 4 times 5 times 5. And I'm going to get brand new fractions of negative 25 over 20. And I'm adding that now to 64 over 20. And that overall gives me negative 25 plus 64 is going to give me 39 over 20. And let's do our last step. Let's convert this to, excuse me, to mixed. 20 goes into 39 one time. If I go twice, that's 40. That's too many. So it goes in one whole time with 19/20ths left over. Okay. So again, we're going to tackle this one. I'm going to take the second number, subtract it from the first because of this notation from that to that. So I'm going to take my first number and convert it. So I'm going to do the conversion in the same, let's rewrite it actually. Let's do that. So I'm going to take this, I'm going to take my first number, 2 and 1/2, and I'm going to subtract 4 and 7/8. All right, so let's convert here. Let's change to red just to show. First, I need to make them both improper. 2 times 2 is 4, and then I'm going to add the 1. That's going to give me 5. So I'm going to get 5 over 2, and 4 times 8 is going to give me 32. 32 plus the 7 is going to give me 39. So I get 39 over 8, and we're subtracting. Well, we don't have common denominators, but we can fix that. Let's just multiply this one by 4, and then I'm going to get an 8. So I have a new fraction. I have 20 over 8, subtract 39 over 8. If I take 20, subtract 39, I'm getting more negative. I'm going to have negative 19 over 8. Convert that. 8 goes into 19 twice. So I have negative 2 times with how many left over? 3. Because 8 times 2 is 16 and 3 to get to 19. So my final answer is negative 2 and 3/8. All right. How about a couple word problems? These ones, it's crucial that you have a picture. I actually will give you part marks for drawing a picture when we're having when we can kind of visualize what's actually going on. So let's take a look at this. I got a diver that's jumping off a cliff that we have at 14.7 above sea level. Okay. After hitting the water, he plunges 3.8 meters below the surface of the water. So the best way to do this is let's use rational numbers. We're going to represent the difference in heights, but we need a picture. Okay, so to do this, I'm going to basically say, okay, well, here is my cliff. Here is my sea level. And what I'm told is that this cliff for sea level from here to here is 14.7 meters and plunged 3.8 meters below the surface. So then going down, this is 3.8 meters below. Okay, so you can think of this. Here's going to be my terrible picture. Here is Mr. Tronis jumping off a cliff. I do not recommend this. I dive off and I plunge all the way down here, and then I guess I come back up for air. So the question says, use rational numbers to represent the difference in heights from the top of the cliff to the bottom of the dive. So I want to get this value. Let's go to black. I want to know from the top of the cliff all the way down here. Okay, what is that distance? Well, we see now with this picture, it's pretty easy. I just need to take the 14.7 and add it to the 3.8. Okay, now when it says to represent the difference in the heights, well, because we're going down, the difference is going to be negative. So I know that's a bit strange. So we go from the second value is in the negative. Okay. So both of these we want to represent as negative numbers because I'm going down. Okay. This is going down. So we're talking about height. This is negative. So the way to think about it is we have negative 3.8, and then I'm going to add more negative height. We have negative 14.7. And now we can see clearly that if I add those up in my calculator, I'm going to get negative 18.5 meters. That is the difference from there to there, because the negative, again, this little negative here represents going down. So negatives indicate direction. This is really important, especially if you take physics later on. How about, what if the water is 5.62 meters deep? How far from the bottom of the ocean floor was the diver, or Mr. Tronas, at the bottom of the dive? So let's just extend our drawing here a little bit. It says 5.62, so maybe about here. Okay, so here's the bottom, and it's telling me a new measurement from there down to the bottom was 5.62 meters. Okay, so how far from the bottom of the ocean was the diver? Oh, sorry, apologies, I drew that picture wrong. It's saying that that's how deep it is. So let's fix that. So that's the depth. How could I fix this easily? Let's just erase that. Okay, let's go back to what I had before, bring that down, and it's telling me that this depth is 5.62. So careful when you read the question, even for Mr. Tronas. 5.62. So this distance here is now asking us how far from the bottom was I on my dive. So my deepest was right here, and I want to figure out, okay, from here to here, what is that value? Okay, so I can see clearly now that I want to take this distance from the sea level all the way down, the depth, and I just need to figure out the blue piece. I just need to subtract this 3.8 meters. I want to remove that piece, and I'll find the piece that's left over. So I can write it as 5.62 meters, and I'm going to subtract the 3.8 meters, and that's going to give me a grand total of 1.82 meters. Now that's how far away I was from the bottom. So when we're talking about just how far away, I'm representing this as a positive value. But in both these situations, you can write it in the other order. I can go 3.8 plus the 5.62 meters is another way to write it. There's nothing wrong with that. And overall, we would get 1.82 again. Either way, however you like to think of it. But again, the idea here is that we have the full depth, and I need to subtract the portion that I already dove and find out what's left over, how much further to the bottom of the sea or ocean floor here. That concludes this lesson, everybody. We'll see you in class to work on the practice.